I want to explain something real quick. Superfluid helium, well, superfluids in general, they they, uh, they have viscosity. It's just that its viscosity is so low that it's immeasurable by modern means. We don't have a way to measure the viscosity of a superfluid, and the reason is because with zero viscosity, the thing is that the mass is being multiplied by gravity. So the mass of the fluid wouldn't pool. It would actually start to almost boil, but it's not boiling. It's really funny. And that the liquid, yes, it likes to run up the side, and that's because gravity is pulling on the mass of the liquid, the center of the mass, and that's trying to evenly disperse so that gravity and its viscosity level can harmonize, right? But the liquid that comes up, it should want to evenly disperse along the surface, and we don't have any zero gravity studies of superfluids as far as I know, so I've had to do them in my brain. In that, because there's gravity, as the liquid reaches a certain point, because of the low viscosity, it doesn't want to be pulled back down. It wants to keep sort of going up to a point where it'll collapse. And as that particle falls, or atom, I should say, falls back down into the fluid, it's encountering zero viscosity. So that means the energy that's in there is only going to be relevant to the gravitational force upon it. But it'll maintain that acceleration, and it'll start to like reflect and bounce. And depending on, like, obviously the surface, if you could have a way of letting it keep bouncing, but all that energy, then it's going to still have that mass that is multiplied by gravity, so that it should essentially just keep doing this and building energy. Gravity at zero viscosity should sort of be amplifying and multiplying itself, but it's not. The only reason that it couldn't be doing that is because there is some level of viscosity thanks to the mass of the atoms and how, well, when you get into my gravitational field model, how you equivalate the two states of mass. So I just, well, I don't know if I discovered, but it's, in my field model, I relate to volume divided by density and density divided by volume to describe two types of mass and how those function together, and how we can correlate gravitational fields based on the charge variables and the volumetric, like, charge variance, and I guess valence would be a better word, but and how that works together. So when gravity and the mass of the fluid form this liquid structure that we call superfluid helium, if it has zero viscosity, that means that that liquid is going to accelerate, and it's going to accelerate by the mass of the other particles involved. And so it should want to just basically thin out and just cycle around the outside of a container. It should not slow down. And it only kind of slows down because of gravity, except for the fact that you have the mass multiplied by the particles. So the mass of the fluid is accelerating that particle by gravitational means. So it should just constantly build energy. And anyway, that's the theory of why superfluids have some margin of viscosity. So it's like a super minimal viscosity, but we just call it superfluids. So it's, you know, so it's a super state, but it's not zero viscosity. Zero viscosity would be really funny. It wouldn't make any sense. You could input a little bit of energy and multiply how much energy you could take out.